This model looks at the Canadian lynx population over time in years using the equation y equals 26,986.1 minus 381.682x minus 6,994.41 cosine of pi x over 5 plus 1,880.02 sine of pi over 5 times x on the interval of 19 to 39. Our model is analyzing the data from 1919 to 1939 of the fur returns of the Canadian lynx, as that is indicative of the overall population of it in those years. After taking the first derivative of the initial equation, I set that derivative equal to 0 in order to find the x values, also known as the critical values. We then plugged these critical values back into the original equation in order to find their corresponding y values and therefore be able to analyze them as relative and absolute minimums or maximums. These relative extrema tell us at which point the population of the Canadian lynx was increasing and then shifted to decreasing, and vice versa. And the absolute extrema tell us the highest population amount for the Canadian lynx and the lowest population amount during this time period. We then found the derivative of the derivative, aka the second derivative, and set that equal to 0 as well in order to find the possible points of inflection. We then put these possible points of inflection on the sign diagram to determine concavity and to find the points of inflection. The points of inflection reflect changes in concavity, which means that at that point the population growth shifted from slower to faster or from faster to slower.
The population shown in this graph indicates how the population may increase and decrease over an amount of time. The reason why the lynx population is increasing is because as the snowshoe, hare, or the prey population increases, the Canadian lynx or the predator population increases as well. At a certain point, or the relative maximum, the population of the lynx reaches its peak as the hare population begins to decrease, no longer being able to sustain such a high lynx population, causing it to decline, which then results in the increase of the hare population, and the cycle repeats itself.
This applies to life right now with our population at 7 billion. Population estimates have it at 8.7 billion in 20 years. However, if a natural disaster, virulent disease, or lack of natural resources occurs, our population may decrease. It is a possibility if we overuse our natural resources that our population may decline. However, that will eventually replenish our resources, which in turn will increase the human population as well, similar to the lynx population.
It's time to go if you don't dig techno.